Hi everyone, my name is Ali and I'm a physics major in Bilkent University first year. And today I'm going to present my experiment for Physics 102 lab project. As you can see, it's going to be about magnetic field strength, and we're going to uh, do the experiment by using a wire and a solenoid and try to examine how magnetic field strength differs with respect to currents and with respect to distance from the wire or solenoid. So as you can see in the picture here, as we move away from the wires, the magnetic field strength decreases there a lot, and for the solenoid as well. So the strongest magnetic field is inside the solenoid, and outside the solenoid, magnetic field strength is very low. And as we move away from the solenoid as well, the magnetic field strength decreases tremendously. So the materials that we need for the experiment is solenoid, copper wire, a resistor to control the current flow, and a DC power supply, and as you can see, physics toolbox magnetometer to measure the magnetic field strength, and a ruler to measure the distance from the wire or the solenoid. So I did the experiment in the lab. So as you can see here, right now there are two different voltages, and as I have the same resistance and I change the voltages, the current changes for both of them. So in the first one, the voltage is 15, and as you can see, the magnetic field strength is around 94 microtesla. And as I increase the voltage, 25 volt, and it became 111 microtesla. And as you can see, the relationship as I increase the voltage and the current, magnetic field strength uh, increases as well, as the distance between two of them are the same. And after that, uh, I we examined with respect to distance, magnetic field strength, and as you can see for the wire, and in the first picture, there's 1 centimeters away from the wire, and magnetic field is 160, and the other one, as we go away, magnetic field strength decreases a lot. And again, as you can see in the picture, as we move away from the wire, the magnetic field strength decreases proportionally. And in the next one, we examined for solenoids. So in the first part, the voltage is constant, by the way, and again we measured the magnetic field strength with respect to distance from the solenoid, outside of course. Then the first one is the next to the solenoid, and magnetic field strength is 50, and the second one is 10 centimeters away from the solenoids, and it became 39. I mean, of course, there are some mistakes and errors in the experiment because of the environment and other errors. But again, it shows us that as we move away from the solenoids, the magnetic field decreases. And again, when we get 15 centimeters away, it becomes 34, decreases again. And after that, we did the same experiment for the solenoid with more wire and more turns around the solenoid. And again, we looked at different distances, 1 centimeters, 5 centimeters, and 10 and 15. And the voltage is constant for all of them. And as we can see, when we are near to the solenoid, it's very high, around 2250 microtesla. And when you get 5 centimeters, you become 1,000. I mean, it decreases by 1 over r cube. And again, when we go away with 10 centimeters, it becomes 700, and so on. So as we can see here, when the voltage is constant, we can see that as we move away from the solenoid, the magnetic field strength decreases proportionally. And in the last case, uh, I compared the two solenoids that we have prepared to see how the number of turns around the solenoid uh, affects the magnetic field strength. And as you can see, for the left one, there are lots of turns, maybe around hundreds of turns of wire, and the magnetic field strength is around 2,250. And when we do it for around 20 turns of the copper wire around the solenoid, it became around 50. The difference is tremendous. And as you can see, the number of wire turned affects the strength of magnetic field. So, and let's see about the conclusions. So, what are the conclusions and takeaway from this experiment? And the first one is magnetic field increases proportionally to the current passing through the wire. And the other one is magnetic field around a wire decreases as the distance from the wire increases. So we saw an experiment and the measurement. We saw all the numbers and all the figures, and we did that experiment right. And the other one is magnetic field strength decline as we move away from the solenoid as well. And the number of wire turn affects the strength of magnetic field. And that was our experiment. And we measured how magnetic field strength changes with respect to current and with respect to distance from a wire or solenoid. And that was our experiment. Thank you for listening. Have a good day. Bye bye.